So if a graph is symmetric about the origin, so that's the one that's just like the most unfamiliar. That is like symmetric about the x-axis, symmetric about the y-axis, all that pretty much makes sense. But symmetric about the origin, what does that mean? Well, first off, I think you get a feel of it. This is what symmetric around the origin looks like. An x cubed graph is symmetric about the origin. And the whole deal about something being symmetric about the origin is that if we take one part, so I'm going to look at this part here, and if we flip it over both axes, we flip it over both axes. So we flip it over the x-axis to land it here. And then we flip that pink graph over the y-axis. Look how it lands right back on the original graph. So when that happens, that is when it is symmetric about the origin. So you see also just some quick thoughts like a circle. A circle fits that description. The sine graph, if you're hip to that, fits that description. And you see just kind of the general shape of it. How if you flip it, like the left side, you flip it upside down and then flip it over, it lands back in on itself. And let's see like the particular points they're looking at here. 4, 2 and negative 4, negative 2. So 4, 2, negative 4, negative 2. So that's like a cube root graph in a way. That's like that graph. That has origin symmetry. And remember how back with y-axis symmetry, what did we say with y-axis symmetry? We said that with y-axis symmetry, f of negative x is the same as f of x. But here, so when we plugged in f of 4, we got 2. But when we found f of negative 4, we got negative 2. So the idea here is that, well, actually, so what is the last step? We do a little substitution. So we say that negative f of 4 is equal to negative 2. So then we say here that f of negative 4 is equal to negative f of 4. So just check that real quick. What was f of negative 4? F of negative 4 was negative 2. And what was f of 4? F of 4 was 2, but then we make it a negative. So that makes sense. And that's like the formula way for testing these. Not with any specific numbers, with x in general. So you go f of negative x is equal to negative f of x. So see, the gist of both of these is you plug in negative x. You find f of negative x. And if it ends up being the same function, but just with a negative pulled out to the outside, then it has origin symmetry. If it ends up being just the exact same function in general, then it has y-axis symmetry. And if it has neither, then it's neither. And that's fine. That happens. So the next problem we'll be doing, we'll be testing that out. So I'll see you then.